All right, welcome everyone. It's Monday, July 29th, 2024. This is starting a new series, the CodeStream. So it's going to begin with first showing one of the main end products, which is this combined visualization of TheBrain archive. We'll go into it more. First, I'm going to push all these edits and updates to the open source repository. All right, we have pushed the edits. Let's check back. Here we are in the active inference repository, reloaded, and we're all caught up. So let's get into it. What is this about? How did this visualization come to be? So first, a little bit on the background and the spirit. The spirit is tripartite, archiving for the brain, using augmented sensemaking. So first, archiving. This was the name of a conference by the American Society for Cybernetics just a couple of weeks ago in Washington, D.C. Archiving. And here's a cool video with Paul and Peter T. and a couple of others sharing what archiving means to them. So that was really inspiring to me. And I thought, in that way, why not archive some of the work that was done today in archiving, also as part of broader work involving open source methods and curation for all kinds of archiving and sense making. So that's the spirit. Archiving, what has been, is being done, what could be done, will be done for the brain in this situation of synthetic intelligence and augmented sense making. What is the brain? Active Inference guest stream with Jerry Mikowski is a great starting point. This stream, he absolutely dances and jumps around a lifelong work. He talks about the platform, the brain, and also about how he uses it. So if you want to check out the brain software, head over to the brain. And where this story picks up is with Carl H., and seeking to develop some methods for mirroring, archiving, and then also repurposing and utilizing, making more actionable some of the content that are in the brain, especially related to tasks. So that's where we're going to get. The way this whole process kicks off is in my login page for the brain. I was able to click these 3 lines, brain actions, and then back up to brain archive. Also, it'd be cool to have that kind of access to some of these other repositories. And this is also building off of the TheBrain API, which we'll get to. So first, big picture, where this open source software gets you is when you download an export of the brain. Here's the .brz file, and then that unpacks to all these files that are in a folder called TheBrain_export. And those are exactly the files with no further modification that the brain export analysis script takes in. So where does it get you to? It makes a sequence of 9 images at this point, saves them all into something called combined visualization.png. And let's zoom in a little bit and see what these 9 are. They're all combinations of the following. First, here's a word cloud. Here's a distribution of the link types. There was 58 links, and they're all of the same type in this situation. Here's a statistical network theoretic analysis. We have 4 different centrality measures: degree, betweenness, closeness, and the eigenvector. And then some of the most connected thoughts. And there's a heat map showing how different centrality measures relate to these common thoughts or linked thoughts. Thought creation over time. It's a plot of the number of thoughts created, as well as an overall accumulation plot. Visualization of thought degree, pretty interesting. Here we have the count in terms of the number of nodes with that degree. which is the number of connections going to a node. And here it's a log plot. So these are exponential scaled axes. And it's pretty interesting, even on this very small TheBrain, to already see a kind of power law distribution. Thought depth, it's a distribution from the first thought added. How many layers deep can you traverse? And it's interesting that it's kind of semi-normally distributed around 3 or 4. Here's a modification heat map. Here we have date on the y-axis going back to 2021, and then hour of the day on the x-axis from 0 to 22 or 21. Maybe it just doesn't plot those extra last few hours. And it's kind of interesting. It looks like when Carl was working on this earlier, he was doing earlier in the day, or maybe there was a difference in the timestamp from June 2021 to May 2024, and then July 26th this year, there was some heavy activity at 1600. Here's a very interesting and promising direction, which is that of network visualization. So here nodes are scaled according to their degree, connectedness, and they're colored according to the type of thought that they are. And then here's a pie chart showing the distribution of different thought types. So 58% of them are normal. Then there's several other kinds, system, type, and tag. So that's the big output. Let's regenerate it just to verify that it's all working. So I'm going to, in Cursor, by the way, cursor.sh or cursor.com, absolutely incredible. We'll be looking into some methods for how this is all achieved. I'm going to delete the folder brain figures. I'm going to clear the terminal. Check where I am in the terminal. I'm in the folder TheBrain, which is exactly where I want to be. I'm going to run the Python 3 script, TheBrain export analysis. So it's running what we have up here. Just cleared it. So the first outputs that come to the terminal are some warnings. Not everything is perfect in the script, but I just wanted to lock in what I did today. It does some output of columns and sample thought and link data. That's really important also for interpretability, and it helps recontextualize the LLM what the columns actually are so it doesn't go off in a different direction. Then in the terminal, there's some summary statistics, the total number of thoughts, total number of links, several calculations that are possible related to the network statistics, listing of the top 10 thoughts by their degree, the depth distribution, these are later plotted, and then the link type distribution, and then some reporting on the general generating of visualizations. So just to verify, here we are with figures, and we've regenerated the combined visualization. We can just delete it. And then again, if we want to clear the terminal, clicking up twice, Python 3, TheBrain export analysis, enter, processing, generating the visualizations, giving this kind of working message, logging the time at which these things happen, and then a couple more seconds. Completion of the visualization. So that takes however long that was, 15 seconds. So what's really cool about this is it's being brought into the active inference repository where there's all kinds of methods ranging from ecosystems of shared intelligence to metaphysics, quadray coordinates, tetrahedral coordinates, all kinds of active inference, free energy principle, as well as many meta and meta-meta handler methods for planning, operating, executing, rendering, visualizing, summarizing, reporting, following up on simulations. So this is a cool package, and I hope that people are interested to explore this. Not all of the code in there is necessarily operational. However, there's a lot of interesting semantics, and as just shown here, the brain export analysis, all it needs is the brain underscore export with the unzipped file coming right from the brain website from someone's dashboard. So that's just a great place to begin. We can then develop all kinds of multi-brain methods, which we'll get to, in a second. So first, conveying the spirit for the stream. How do we archive archiving? Share a little bit about that sensemaking, about sensemaking for the brain platform and using these synthetic methods like code. So first, I showed the visualizations that were generated. Now let's look through the code and then cover how was that analysis generated. So heavily with large language models. Let's go a little bit deeper. There may be other ways to, of course, update the script, but this is just where it got to, and some of the historiosity is actually captured in these minute by minute saved files. 3:13 p.m., 3:30, 3:36, 3:47, 3:58, 4:07, and those were only some of the versions. But as we'll look at in a second, the feedback loop, the actinf loop, OODA loop, however you want to think about it, is extremely rapid. So first, there's a import section. Python scripts are, just sort of speaking generally here, often written in a style where beginning are all the imports and methods that are brought in from packages that are installed or other things in the folder or in the repo. A class called TheBrain export analyzer, top level class, is defined, and some information about how that top level handler should be set up. Then these def are methods that get called up in various ways. So there's import thoughts that scrapes and brings in the JSON of the thoughts and the links. Brain details I don't think actually exists, so that's one funny thing that I kind of kept around. Possibly it could be a prompt to fill in brain details.json or find some other way to bring together a few of the pieces that are referenced, but it doesn't halt the rest of the process. Verify import double checks that there's a verification of the import. Printing section headers, a method for visualizing in the terminal. Printing summary statistics, similarly, it's a method for printing summary statistics in the terminal. Calculation of summary statistics calculates the summary statistics, which are then printed to the terminal. Here, there's a variety of summary statistics, the centrality measures, etc. Printing summary, print summary. Some of these methods may even be redundant, but it doesn't stop what we just saw happen. Printing top thoughts, prints the top 10 thoughts by degree. Here's the depth distribution printing. Here's the link type distribution printing. Here's a high-level function on visualizing data that generates all of the visualizations. Here's the visual method specifically for thought creation over time. Some of these methods could be reorganized. So again, I'm just kind of locking in where I got to today, but it's just the starting point for tomorrow. Visualization method for thought type distributions. Generation of the word cloud using the word cloud method. Visualization of the thought network. Visualization of the link types. Visualization of the thought depths. Some of this, upon rereading with a different lens, it does look possibly redundant, but we can try to experiment with that and condense it in the latter part of the stream. Visualization of the thought modifications. Visualization of the thought degree distribution. Amazing. Visualization of the thought centrality in comparison, the heat map with the 4 centrality measures. Get brain details, which again is looking to this brain details file that I don't think exists. And then running analysis, which is the analysis stages. And all those are definitions. Then the main, so-called main of this Python script just loads it all up and runs through it in the order that the logic flow suggests. So this is several hundred lines of code, 518 lines of code. And how was it reached? So for that, I'm going to pull back to a little bit about how I'm using Cursor at this time. It's just one way to use it, only one of the ways that I have been using it. But this is hopefully some tips that people may find interesting, whatever their level of programming experience is. So here's a script called clone GitHub repos. And clone GitHub repos, I'm not going to walk all the way through. I'm just going to highlight that at line 53, there's a comment that says flags to determine which categories to clone. So here, TheBrain, GTD, and Gantt are true, which means it's going to clone repositories under those categories. Here's the specific repos under TheBrain, GTD, and Gantt. while Noster, synergetics, ants, active inference, multi-agent LLMs, task execution AI, AGI, multi-agent AI, general LLM resources, social media interoperability, and holochain are false. But you can set any number of these to true or false. So to keep it a little bit fast, I'm going to set GTD and Gantt to false. So only TheBrain is true. I'm going to clear the terminal. Right now I'm in the TheBrain folder within 9 other. So first I'm just going to use ls to print where I'm at. I'm going to use cd ... to pop up a level and then check that I'm in where I think I am with ls. I'm going to go up and use a bunch of up clicks and then control delete to delete that last argument. So now I'm preparing a Python 3 call to clone tab GitHub _ this is the bifurcation point between GitHub repos and GitHub users, r tab clone GitHub repos. So I'm also going to delete this repos folder just to show how it can start from fresh too. I'm going to hit enter the target directory. Default is repos, and it makes it if it's not there. So here we go. We're successfully cloning into these repos that are using a variety of different techniques with the brain. The more that's there for Cursor to work with, the more that's there for the LLM to learn, the better it is. The less fabricated falsities are there, the more veridical the semantics are. Now I'm going to go up to this gear up here, cursor settings. I'm going to just, again, to show it from scratch, I'm going to delete the index. This is the vector embedding. So while it's indexing, let's think about what it's doing. It's taking the code and running it through the first kind of step in the language model, which is it takes the tokens, tokenizing, etc. I'm not going into all the details here, and it converts these strings and these chunks into a vector representation. So it's like a list with a bunch of numbers in a given dimensional space. This means that when I type in a prompt, it'll know where to look. It then brings in the semantically relevant sections of code into the context window for the LLM, and then uses that to fulfill the request. So just as I'll do TheBrain _ example CodeStream.py, but it could be any language. In fact, it's excellent at doing different languages. There's 2 modes of using Cursor. There's the inline code editor with Control K, and I'll start there, and then I'll show Control Shift L next. So I'm going to say, given the total status of the code base, please write a comprehensive. Some of these adjectives may or may not matter. It's just fun to think that way. Please write a comprehensive suite of methods that characterize what the brain is, describe the API, and pull relevant methods. I'll just note that the API I copied from the Brain API documentation, and I brought it in the Brain old. Here it is. Here's the LLM generated summary of the API schema. So here I just unfolded everything I could on the website, copied it into this plain text file. Then I selected all, Control K, and said distill the semantics so that it's maximally informative for another language model. And so that's one thing, and it may have deleted some lines, etc. Let's go back to where we're doing the example. Green means that it added the lines. So here, let's just see what it wrote. We have the Brain API. It's a class to interact with the API. It has a bunch of definitions. So here, let's use Control K again, develop, expand, and professionalize this. Adding an import statement. So while this is happening and making these updates, red deleting a line, green adding a line. So if there's a red and a green next to each other, sometimes it's just deleting one thing and adding other things. And you can get down rabbit holes and paths that are locally optimizing and making the global situation deteriorate. So it isn't that every edit it makes is in the biggest possible scope helpful, but there's a ton of useful methods. Again, the key piece was that first I used the clone GitHub repos or clone GitHub users to bring in as much relevant code as possible. Reindexed using cursor. This is version 0.38. And then use that to have more of a grounding in the semantics and the syntax of what I'm trying to work with here. So now let's use Control A for select all. Control Shift L pulls what was selected into the sidebar chat. So here we could ask various different things. We could ask it to make an edit to the code that does such and such. Make an edit to the script so that there are improved text outputs to the terminal. Here, it is actually consulting the web. Here's the web pages that it's consulting, as well as local code. And then it's going to write this updated block, but it doesn't directly overwrite what we have. It writes it in the sidebar. So it's going to finish writing it in the sidebar, about 79 lines a minute. So these are some improvements it's making. And then I'm going to apply it. Apply. Now it does a really quick pass because it kind of knows what needs to happen, uses this updated code, and then runs through the script of interest and makes the edit. So I'm going to accept these edits, and then I'm going to start a new chat and show something else you can do with this. Okay, accept it. Control A, save. I don't think that is needed. Start a new chat with the plus. Control A, Control Shift L. Write many fancy poems of different and multiple styles about this script. So this is just highlighting that this is using GPT-4o. We could also be pulling from Claude 3.5 Sonnet, which we can do next. Here we go. So Sonnet, hilarious that the first version of poetry that the GPT-4 uses is the sonnet. In Python's realm, a class of might and grace, the Brain API stands tall and true, with methods crafted, each in its own place. Hilarious. Haiku, API of thoughts, Python's wisdom in each call. Brains connect and grow. Limerick, free verse. Villanelle, write poetry like William Blake, fused with Buckminster Fuller, giving an active inference perspective on this very script. That's just a fun one. Let's see what it does. A visionary poem about the Brain API. Active inference, the dance of thought. The fusion of minds, Blake and Fuller. Incredible, incredible. Saving this. Now, let's go to the to-do, and let's just take a quick look at how one of these to-dos might be implemented. But here's just a few things. I wrote up a couple words like to kind of recapitulate how I made the to-do. I'll do CodeStream to-do.py. So now we're just going to start on a fresh page. I'm going to think, well, I know that we want getting things done, productivity tools. We want to have lump and split across different TheBrain instances. We want to have connections with decentralized social media. Control A, Control K, develop and expand these to-do suggestions I am having into something absolutely comprehensive. accept it. Step 1, getting things done. Productivity tools. Give some subtasks here. 2, lump and split across different TheBrain instances. 3, connections with decentralized social media. So what I'm going to do is I'm going to take the export analysis, kind of leave it as is, and let's just explore first this getting things done. But if anyone's watching live, please feel free to add like a comment or a question, and I'll see if I can address it during this short stream. Okay. I'm going to, in TheBrain, I'm going to make a new folder called CodeStream 001, just to make clear what we're doing in this stream. New folder, new file. CodeStream 001, getting things done.py. Here, with reference to all possible real extant code, please write a getting things done meta handler so that there can be actionable intelligence being pushed and pulled in the multi-scale self-concept of cybernetic self/organizations specifically related to getting tasks done in different projects. Okay, GTD meta handler. Using the kind of semantics and even terminology that I did. Accept it. So what's going to happen? GTD meta handler, add some things. I'm not even reading them in detail. Let's look where we are in the terminal. We're in 9. A CD into TheBrain. LS, I'm going to CD into CodeStream LS. Clear? LS, just to see where we are. So we're in the terminal, in the folder where we are looking at the script, the CodeStream 001. I'm going to hit up a few times just to get the Python 3, Control Delete, delete that term. And now do this on CodeStream 001. That's a bifurcation point, getting things done. So let's just see for a first pass, I didn't make any edits, what happens when you actually run the script. Okay, nothing happens in the terminal when the script is run. So I'm just going to start, even though this isn't necessarily the only way to pursue this task, also switch models into Claude 3.5 Sonnet just for fun. So when I run the script, there is no output to the terminal. Please update the script so there are verbose and truthful summaries of what steps are happening and derive a variety of intermediate forms which are useful for future visualization/utility regarding tasks from the brain export. In the sense of at the brain _ export analysis. So now it's going to actually use the task representation from the brain export analysis. Okay, here we go. That was in the side chat. I could have also done it in the Control K inline. So here it is. It's updating it. Let's just let it finish and then see what happens. Next action, starting to smell like active inference. Here's the updates that it suggests. Scroll all the way back to the top, hit the play button, continue. Now it's going to quickly run through here. adding a bunch of logging expressions. Now it's adding a bunch of new methods. And it's done. Control accept. Save. Starting a chat just to make clear. Clear. Twice up. Enter. Still got no output. So I'm going to Control A, Control K. Please update the script so that it gives verbose output to the terminal, drawing exactly from the tasks inferred from @TheBrain _ export analysis. Follow that line. Here, it's adding methods. Again, some of these could be redundant. Some of these could be fallacious. Clear. Running the script, still nothing. So I'm not going to go continually, but this is just something where you don't really know if you're one tiny bug away from resolving the issue or if you're much further. And here's an example of, let's just take this current export analysis and let's make a variant here. So I'm going to call this one export analysis. Let's call it active inference. Okay, so now I'm in this copied version. Pop up cd // ls, so we're in the right folder for where we are. Clear. Okay, now I'm going to also change to Claude 3.5 Sonnet for this chat. They're all good. Control A, Control K. Please update this to integrate active inference and free energy principle as per the infer_ants repository, which surrounds this script so that the sense-making and decision-making of the augmented user is being mapped / described using an active inference partially observable Markov decision process in discrete time. If I had in the clone GitHub users or repo pulled more from active inference notebooks, then we would have a lot more syntactic information on how to actually use the schema. So let's just see how it does for now. Looks pretty good. Observations O, actions E, transition model B, observation model A, policy prior pi, initial state prior D. Looks pretty good. Okay, initialize active inference components. Still chugging through. Let's see where this gets. This script is getting a little long. I've noticed that Cursor does better with shorter files. So one of the next steps is to break out the loading method from the visualization methods, etc. But let's delete the figures and see how this works. Python 3, we want the brain export analysis _ active inference.py. Okay, perfect. Here we got an error. I'm going to debug it with AI. So the brain export and analyzer object. So there, it has all this information. Looks like much of it works, but then it catches an error. So debug with AI. Takes that chunk, throws it into the chat on the right, and then it is going to do some, it's a side conversation fixing the error. So I'll just say fix the error. Sometimes you have to explicitly say fix the error, even though its initial prompt should be doing that. So it's looking online, it's looking at local code, it'll make a variety of suggestions. This might be getting super far into the game, but let's see if we can follow it up a little bit. Please write a simple fix for getting the terminal output to be perfect without invoking any more packages or methods. Just describe in the terminal and in a new combination image everything about how the active inference situation is being modeled in the brain. Looking at a lot of the previous okay, here's the new describe active inference model. Replace these lines. Okay. Okay. Remove the problematic lines. Accept that. And describe the model. Accept that. Control Y or clicking that, or you can just accept all. So now, clear. Let's run it again. Okay, it's generating the visualizations. So that just showed that the introduction from the brain export analysis with active inference, it kind of threw one error. But now, if this completes, then let's look at the figures. I didn't even read the code, so let's see if there's like a new active inference figure. Wow. 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 Here's the active inference model description, giving one of the most interesting responses about the shapes of the variables. So now let's make a new figure output for any and all possible active inference visualizations. For example, drawing rectangles for the shapes of variables, edges for if/how they are connected, and or any other ways to visualize active inference as used in this script. Meanwhile, I'll start a new conversation. I'll say, how is the weather, comma, over where/when you are? The weather network. So here, it did a big deletion. So I'm gonna just reject this edit because I think I may have said something wrong. Okay, ignoring that weather question. Okay, I'm gonna control. So instead of doing inline, I'm gonna do Control-Shift-L. Here, write a new visualization method that outputs active inference related visuals as figures into the TheBrain underscore figures /. So here I'm hoping that the long script is going to be able to be distilled down in the side chat, and then instead of trying to make an inline edit to the actual script, it's going to extract the relevant syntax and semantics. Here we go. It's looking kind of cool. Here's how to modify it. Here's how to modify it. All right. So now it knows kind of what needs to come in. Then it'll do much better, I believe. So it's able to skip over those things, whereas previously it kind of like deleted them. Okay. Adding the active inference. Hashtag add this line. And then there's a ton of new code still pumping. It may have to modify, it may have modified its base method. So now it needs to do a little bit of modification down in the combined visualization that we already knew. Okay, almost there. Almost there. Accepted. 697 lines. We're getting up there. Okay. I'm going to delete the figures folder. Now, starting a chat. Clear. Terminal output. Double click up. Run the active inference script. Here we go. So again, as per the previous one, we have some samples, some summary statistics. Now we're generating the visualization. So let's see. And even while it's running from a saved copy, I can say add terminal outputs. Okay, it gave an error. So I'm going to click here, debug with AI. But it did make active inference folder. So I'm going to say fix it. While I'm saying fix it, let's look at what it did. Wow. Wow. Here, it literally did a from and to. It did a B matrix with the 53 notes. Here, the policy prior. That's kind of funny. It only has one action, so it doesn't know about pi yet. But it is, I guess, a simple one. And then here is the observation model. So this is an identity matrix. So this is a noiseless A matrix. It's able to know exactly which latent state it's in given the observations. It's a one-to-one. Now, let's just, while that was happening, let's apply this. So that was just debugging from the terminal output that was giving an error. Here it's skipping through super fast because it knows where to look. Here's a bunch of edits. Okay, let's see how this goes. Clear. Run the script again. Control Z, I'm just stopping the script. I'm going to delete the figures folder just so that we know that it's clear. Clear it, Python 3, run it. Okay, generating the visualizations. Here's the earlier visualizations, which we know worked. Depth, degree. Okay. Bool has no attribute all. Let's fix this one. Fix it. Okay. Then while it's printing that, let's pop over. Let's see what it outputs, if it does kind of what we're looking for. To fix this, we should add a check to ensure self.policyPrior is not none. Okay, apply it. Just one edit, save, delete the figure folder, clear in the terminal. Run it again. Okay, here's the visualizations that we know work. And there's the error again. I'm going to debug it again. So as mentioned earlier, it's sometimes hard. Like, are you one tiny piece away? Fix this. Are you one tiny debug away? Or are you a whole colony of nestmates away? That's always the question. Here's the modified version. Let's update the method. Play. Apply. Okay, here it is. It kind of zooms into the end. Accept it, save, delete the figures, clear the terminal, run it again. Here it's generating the figures on the left. 3, 4, 5, 6, 7, 8, 9. Okay. Again, similar error keeps on coming up. Let's see what we can do with it. Fix this by removing the plotting. Fix this by initializing the variable correctly. Let's give one more try with fixing it, and then we can just remove the method if it's like still not working. Meanwhile, I'll just give another random example. Like here's salt fat acid heat.py. Control A, Control K, develop and professionally improve this. So this is based upon the salt fat acid heat cookbook. So this is just kind of fun, but it's also super useful. It's building ABCDE. It's another active inference model, but here it's like for a chef. So I'll just accept those and save it, close that file. Okay, try again. Certainly. Let's modify the initialization to ensure it's array-like, even if there's only one option. It could have been quite a headache, but instead, it was delicious. Okay, apply. That was just a fonts glitch. Accept it, save, clear, delete the figures, Python 3. Generating the visualizations. Still giving errors. So let's see if it can debug it. Fix this script by removing the need for plotting the policy distribution. So it'll just strip out the policy distribution component. Let's just see what the other visuals look like and then see how we would go from there. Okay, apply. Meanwhile, I'm going to clear terminal, load up the Python command. And run it. Okay, here's the figures we know work. Okay, we're still getting it. Fix it, removing the problematic method for now. We can always bring it back in. Okay, removing the policy prior. That's what was giving the issue. Let's see what it does though. Meanwhile, clear it out. Clear the figures. Run the active script. I want to end it. I also kind of want to fight through. But this is like day by day. The epistemic slot machine. How fun it is. Okay. It didn't complain. Ensure that all the active inference single figures are output to the brain underscore figures slash. And then on the right side, I'll say, tell me a funny active inference joke. Here's an attempt at an active inference joke. Why did the Bayesian brain refuse to update its beliefs? It had too much prior conviction. I apologize if that wasn't very funny. Humor about technical concepts like active inference can be quite challenging as it requires a deep understanding of the subject matter and a knack for wordplay. The pun on prior conviction refers both to strongly held prior beliefs and the legal term, creating a somewhat humorous juxtaposition. Somewhat? Claude? That's incredible. Clear it. Delete the figures. Let's see if we can get it. Debug transition model. Fix it. We may want to remove the policy prior. That was the one that was giving issues, but maybe it's resolved now. It was working. That's why it's like it moves so fast that you could do a GitHub push every single prompt and try to trace it. Okay, now just to show that this is a side chat. Oh. Policy. Okay. Here it's a different error. So here, if you're getting different errors, you might just be crashing through some, you might be getting closer and closer. But sometimes it's a little hard to tell if you're going down a path that's actually confusing and it's just winding itself into circles, writing redundant methods, giving all these problems. Okay, clever approach. Let's see if that works. Clear. Removing the figures. Double up, Python 3. So it's removing the visualization functions adds a new block of code to creating the 3 subplots first. Then it calls each of the 3 visualization methods, and that might address this axis error. Okay. Still giving an error. Here, I'm going to comment out this one and just see if it'll do the other transition model and the state prior. Clear, delete the figures, run the Python. Okay. I do not want an active inference combination plot. Please output the active inference visualizations in separate functional files. See if you do this in a way where even if one of the plotting methods fails, it will still save/output the working images. This is kind of like getting down into the weeds with this one active inference visualization, which I know is like multiple steps away from the whole archiving. Or is it? But I just want to follow up and just give an example of how do we pursue when we're getting bugs, we're out in the field, in those synthetic fields, finding bugs. What do we really do? Okay, it's moving through. I used the Control K, so perhaps the Control Shift L might have been better there. Okay, here we go. Separate active inference visualizations. Accept it, save, clear, delete the figures, run Python. Update the script so that the active inference visualizations happen before the others. That just will give us like a slightly shorter feedback time. Because we're getting into the bottom of the 9th here. Explain this error in terms of an elaborate American baseball analogy/narrative. While we're watching this. Okay, moved it up. All right, let's step up to the plate and swing at this error with a baseball analogy. Imagine you're at the World Series and it's the bottom of the 9th. The pitcher, Seaborn Barplot, winds up and throws what looks like a perfect fastball. Policy Prior swings with all his might, but something unexpected happens. Wow. Wow. Clear. Delete the figures. Run the Python. Here we go. Now we're getting a faster error. Fix this. Just a few more minutes either way. But I really want to see if it can be done. Maybe we'll flip back to GPT-4o. All right. Accept it, save, clear, remove the figures folder, run the script. Okay, I'm just going to comment that one out. See if we can clear it. Oh. I might try something radical. Totally fix it. Remove the need for any AX stuff. Can it do it? I don't know. Maybe this is too big of a jump. Update, update. This may not work, though. Clear. Delete the figures. Okay. Last try. If it gets the same error, then we'll leave it for tomorrow, / anyone who's watching this and wants to make a contribution to open source. Or maybe we'll try GPT-4o. Save it. Run it. Okay. We got somewhere. We got the transition model. Flipping to GPT-4o just in case it's better at this task. Debug. Almost there. Wow, the policy prior is giving me the challenge. Okay. Here's the chain of thought, helping itself reason. Fix it. Okay. All right. Then we'll push all these updates. Okay, could it really just be that one line? Delete the figures, clear, run it. Okay, we just pushed one deeper. But it seems like GPT-4o was actually able to figure that out. Fix this however you can. Just that. Just fix it. Delete the figures. Clear. Run the Python. Transition policy. Oh. Okay, we're back to looking at the how the state prior S is defined. Change the visualization method so that the current exact shape will give me no problems. All right. Apply it. Accept it, save it, clear, delete, Python. There we go. There we go. Incredible. Amazing work, cursor. Amazing work. Policy prior, there's only one action, so it's a deterministic single affordance. Active inference transition model, these are the transition frequencies between different transitions, states, notes, thoughts. And then here's a uniform distribution across the 52 or 53, zero index, so 53. So it's like our starting position, the latent state, is equal across all of them. So, wow. Well, I'm glad that we stuck it out, that we fought to the end. And it's just the end of one day. So, hopefully this has been interesting to people. And I'll push the code, and that'll be the end of this. GitHub desktop. CodeStream 1 updates. Control Enter. Push origin. And reload the page. There it is. I'll just add the active inference one into the code stream. Actually, I'll just leave it where it is. So, thank you for watching. Looking forward to continuing all the archiving, etc. Okay, thank you. Bye.